Today, we're diving into the three renewables you hear about the most: solar, wind, and hydro. They're at the center of almost every conversation about the energy transition, so we'll cover their strengths, their limitations, and the geopolitical risks that come with them, which often go unexplored. Because it's not just about whether the technology works, it's also about who controls the resources and supply chains that make them possible. Okay, let's start with solar. The strengths are clear. Panels are cheap once they're built, they're modular, and they can scale from rooftops to giant solar farms. Costs have fallen dramatically in the last 2 decades, and growth has exploded. To give some context, between 2016 and 2022, solar has been growing by about 26% per year, effectively doubling every 3 years. By the end of 2022, global installed PV capacity surpassed 1,185 gigawatts, supplying over 6% of global electricity, up from only about 3% in 2019, and up to about 7% in 2024. This explosive growth has made solar one of the fastest expanding sources of electricity on the grid. But here's the limitation you can't get around. Solar is intermittent. It doesn't produce at night, and output drops on cloudy days. To really scale solar, we need massive improvements in storage, and right now, battery technology is expensive and limited. Then there's the geopolitical angle, which doesn't get talked about enough. Solar supply chains are dominated by China, and I mean dominated. From polysilicon production all the way to panel assembly. That means the world's solar build-out is tied to Chinese manufacturing capacity and Chinese policy decisions. It's worth remembering, in the 1970s, the oil embargo showed the risks of being dependent on one region for a critical energy supply. With solar, we could be facing a similar vulnerability, just in manufacturing instead of oil fields. Even more troubling, a significant share of that polysilicon comes from Xinjiang, where Uyghurs and other Muslim minorities are subject to forced labor under oppressive conditions. Estimates suggest that nearly 95% of solar modules globally may contain Xinjiang-derived inputs. Governments are starting to respond. The US passed the Uyghur Forced Labor Prevention Act to block imports tied to Xinjiang, and the UK has passed a softer measure aimed at its own clean energy body. But critics say it's not strong enough. Another challenge is that a lot of these components are rerouted through countries like Malaysia or Vietnam, where they're re-stamped as if they originated there, making it far harder to know their true source. Next up, wind. Wind power works well in the right locations, especially offshore, where turbines can produce steady electricity with relatively high efficiency. In some regions, wind is already the cheapest new source of power, and in 2024, wind generated about 8.1% of global electricity, even higher than solar, although it's worth noting that solar is growing at a much faster rate. But again, intermittency is a huge challenge. Sometimes turbines produce too much power, sometimes none at all. And the best wind resources, like offshore coasts or remote plains, are often far from the cities that need the power, which means expensive new transmission lines. In addition to this, manufacturing large, durable, flexible turbine components is no small feat. Engineers describe modern turbine blades as technical headaches. They must withstand immense stress and weather extremes, making design and production incredibly challenging. Wind also has a supply chain challenge. Turbines rely on rare earth metals like neodymium, which are mined and refined primarily in, you guessed it, China. That creates the same geopolitical dependency that we see with solar. And then there's local pushback. Communities object to the noise, the sight lines, or impacts on wildlife. On the bright side, wind farms are delivering local economic benefits through land leases, tax revenue, rural job creation, making them more politically viable in many regions. Finally, let's talk hydro. Hydro is different from solar and wind because it can provide steady, reliable baseload power. Dams can ramp up quickly to meet demand, and they can last for decades once built. But hydro has limits too. You can't just build dams anywhere. You need the right geography, and you need enough water. And climate change itself threatens hydro. Prolonged droughts and changing rainfall patterns are already cutting output in some regions. On top of that, dams come with environmental and social costs, disrupting ecosystems, displacing communities, and creating tension between countries that share rivers. And reservoirs in warm climates can emit methane from rotting vegetation, an often overlooked climate drawback of hydro. Globally, some countries rely on hydro exclusively. In Africa, 41 out of 54 nations have hydro plants. Several countries, like the Democratic Republic of Congo, Ethiopia, and Uganda, get over 90% of their electricity from hydro. In Canada, hydro accounts for 60% of electricity, and certain provinces rely on it for over 90% of power. Okay, hydro is deeply political. Many hydro-capable rivers cross borders, and upstream dams can shift power dynamics, altering downstream water flows and power access. For example, the Mekong, which runs through China, Myanmar, Laos, Thailand, Cambodia, and Vietnam, and the Brahmaputra, which runs through China, India, and Bangladesh, are transboundary rivers. When one country builds dams upstream, it can affect water flows, fisheries, and farming downstream. Not to mention the power dynamics. The country that controls the dam holds the leverage. If they restrict flows or prioritize electricity exports, neighbors downstream may face water shortages, floods, or agricultural disruptions. That makes every hydro project not just an energy issue, but also a diplomatic and geopolitical issue. Ethiopia's Grand Renaissance Dam has triggered major conflict with Egypt, which depends on Nile waters for survival. India has hinted at restricting Indus River flow to Pakistan, potentially destabilizing peace across the region, underscoring the importance of hydro cooperation treaties like the Mekong River Commission and the Indus Water Treaty. So what do we take away from all this? Solar, wind, and hydro are essential to the transition, but they're far from silver bullets. They are intermittent, geographically constrained, and tied to fragile supply chains. And those supply chains come with their own geopolitical risks. The energy transition isn't just about engineering. It's about economics, politics, and strategy. And that's why the road ahead is so complex. In the next video, we'll shift gears and look at the fuels we still rely on today: oil, gas, and coal, and why moving away from them will be one of the hardest challenges of all. Thanks for watching, and I hope you learned something new. If you'd like more videos on energy and geopolitics, don't forget to subscribe. And I look forward to chatting about energy in our next video.